Okay, good morning. So this is my ROS individual presentation. So I'll begin by showing you the warehouse, and then I will show you my map, the original map and the keep out map that has been done. Then I'll explain the whole setup process, how to do the navigation too, and finally I'll show my GUI with my enhanced features and analysis methods. So first I'll begin by showing you the warehouse, what it looks like. So for that, launch the terminal. Right, so in terminal 1 we will launch the warehouse. Okay, so this is the warehouse as you can see. So it meets the fulfilled requirements of having a 3x2 arrangement. There's an entrance, there's an exit, and there are multiple windows. So the racks are filled with beer cans. And now the next step. So for the next one, I will show you my mapping. So this mapping was done, this was the original map. So I mapped the outside and the inside of the warehouse. So you can see all the racks, the tables, and all were plotted. So this was without keep out zone. So to make it clearer and to have the localization perform better, keep-out zones were made and the walls were made slightly a bit thicker, just so the robot has better localization and it knows where it's going. So now once this was done, the next terminal will place the bot in the warehouse. Okay, so this location was chosen as the home location, so you can see the bot has spawned due to its wide space and open arrangement. Okay, in the next terminal, I will set the URDF. These are all basically map to parameters. Okay, once this has been set, terminal 4, I will separately launch the localization. By right, the localization can be launched with the nav2 parameters itself, but due to some initial errors, I troubleshooted and found that this was the best way. So then in the terminal 5, okay, here I launched the nav2 parameters. And now for terminal 6, I will launch my RVis to show you the map. Okay, so this is the map as you can see, it's placed. So right now navigation, localization and feedback are unknown because I haven't set the initial pose. So to avoid any human error, I use another terminal to manually set the initial pose. So this avoids any confusion for the bot. Okay, so it has been set. So now as you can see the purple and blue lines. So these are the inflation layer. This is where the robot will avoid. So now let me show you how the 2D pose works. So I'll place the robot on this side and the iris here. Okay, so now let's say I'm going to move to this point. So I'll just move the bot forward facing this way. So as you can see here, the robot begins moving. It's going to navigate in front of this rack. It takes a bit of time because I've adjusted the speed so that it's minimal jerk. So it slowly accelerates. Once it's reaching the point, it slows down. Okay, so now the robot has reached the position I want it to go to. So now let's say I want to move it towards somewhere near the entrance here. Okay, I have to, I'll put it here and face this way. Right. So now you can see the robot has chosen the best path. It's moving. It might seem really close to the cabinets, but that's due to the thin inflation layer. So this is to give the bot space. The initial default one, the inflation layers were too thick. It used to confuse the localization. Okay, the bot should be, now it should just turn around because I made it face this way. Okay, so it's reached. Okay, so now that we know the basic nav2 works, the next step was to do the enhancement with the GUI. So this is to see the analysis methods and all. So let me just launch the GUI. Okay, so as we can see here, this is the whole GUI, what it looks like. So a quick explanation. So on the left hand, you can see this the beer warehouse full analytics dashboard. So you have the total bill on the top left panel, and then you have the advanced performance metrics below, which we will make a few trips and we'll look at the performance of the robot itself. Here under locations tab, you have the main locations which were set using the publish point previously. So you have entrance 1, entrance 2, home position is where it started, and the lounge area is where the tables are, as you can see. Next, for beer pickup, the user can select which beer they would like to go. The price is there, so the bot will locate, it will automatically move to that point and pick up a beer. Once the beer is picked up, the total bill will update itself and the live status log as well, it will show. So how many you picked up and all will be shown here. Custom route is for the user to add their own waypoint if they want to go somewhere else. And lastly, set post. Set post should only be used when the robot is back at home. This is to basically reset the localization. So the robot knows exactly which position it's at. If it's used in another point, it will confuse the whole localization and the navigation will be messed up. So on the top panel, you can see we have the live status log. So here we have the beer warehouse, a full analytics system. So the user can track locations, whatever basically goes on with the timestamp will be shown in the live status log. In the bottom tabs here, we have the navigation path first. So here the user can actually see the green dot here is the board right now. So paths it takes will be shown down here. Velocity profile, which will basically show the increase of the velocity and slowing down, basically how it moves to avoid jerking. Activity heat map, we will have the areas where it's most frequently visited. So let's say, for example, the user goes to Tiger Beer very frequent. So that area in the map will be a red spot. And the purple areas are the places it doesn't go. And lastly, for build history here, once we run, the user can see where it goes to. So now okay, let's say now I'm here, right? Now I want to get a Tiger Beer. Okay, so I'll just press the button Tiger, that's it. So live status log will show moving to Tiger. Here you can see the path the bot is taking, and on the right side you can see the bot moving. So it should go and stop somewhere around here. So you can see the path is being taken, velocity profile as well. It accelerated, now it's moving at a constant speed. Okay, and I want you to look at the total bill here. It will update the minute the robot reaches the spot. Okay, robot's there. Now look at this total bill. Okay, 12 ringgit. You see, it reached the tiger and it took a total time of 43 seconds. And it added 12 ringgit. So total bill is now 12 ringgit. Okay, so the analysis we can see here, but let's make a few more trips so we have a better overall picture. So now let's say I want to go and get a Carlsberg up here. As you can see, the robot is successfully navigating. Yep, it's moving. All the live statuses are being shown up there as well. Bill history we can see here, activity heat map. We need to make a few more trips before it shows exactly. Alright, okay, so now the next one has been picked up. The total bill now has been updated. So now let's say the next one I want to get is a just right beside. Okay, I'll go and get a Heineken. Okay, so now the bot starts moving. Okay, so it has reached here. This total bill should update as well. Okay, now next let's go back and pick up one more tiger. So as you can see, it takes the best path possible. Okay, velocity profile shows smooth increment and decrement. So this was made to avoid jerking. Okay, the visit history as well is shown here. Now let's say I go and pick up a block right on top corner right. Okay, as you can see, the robot is moving. On the left panel here, you can actually see the type of beer, the brands, and the price, as well as the times it has visited. So just now we visited Tiger twice, the rest about one time. So now I'll pick this up. Okay, the bill should update one more time. Okay, so now let's say I'll go down right below and pick up a Guinness stock. So the live status tab as well says everything with timestamp, how long it's taken, and if you want to know the actual locations of everything, it is all written here. See, 1050 negative 0.18. That's where it's headed now. Okay, so now let's say the user wants to go towards the exit. Okay, so I will basically just press go back to my locations, okay, and press entrance. Now let's say, okay, before he goes to the exit, let's say he wants to go to the home position because that could be where the cash register is for the user to pay. So I'll go home. Okay, so let's say imagine there's a cash register here. Okay, so now let's say the user feels like he wants to go towards the lounge area. Okay, after he's paid, he wants to go and enjoy a nice beer or something. So now let's put lounge area. So the robot should be moving there. As we can see, a can has been dropped here. So by right, the path, it should cross this, but with the LiDAR's obstacle avoidance, it should avoid. So let's see if it does. So as you can see here, it says moving to lounge area. Okay, it's approaching the can and it should make a left turn. Yes, perfect. It avoids. It went around it instead of just directly curving. Okay, so now we know our obstacle avoidance works. Even these tables. Okay, let's say now the user stops here. Okay, wonderful. So now, okay, now we know that the robot can successfully move. Let's look at the analytics and how it works. Okay, so from the performance metrics, we can see the total distance it traveled, the whole from the beginning was about 51.6 meters, I'd say. Average speed is about 0.18, which is constant. We can look at it from this velocity profile. So as you can see, every time a location is clicked, it slowly accelerates, moves at a constant speed, and gradually decelerates. Same max, the max speed it will go is 0.25, and that's when it's at a straight line. So it knows exactly where it's going. So you can see the velocity profile here is excellent. It moves according to what it should be. Okay, the goals complete 8 over 8. So it completed all its mission. Path efficiency is 91.8%. This is excellent because it's avoiding going from a straight line. 100% would be when the bot takes the shortest line, the straight route, the straight line. So this one, it takes 91.8% because it avoids obstacles, but it's still taking the shortest path. Smoothness score is basically the avoidance for the bot to jerk. So it moves straight, slowly, slowly, slowly. Then it will once it as it picks up, it slowly moves, then it accelerates throughout the continuous path. Once it's starting to reach, it will slowly, gradually slow down, as you can see from the velocity profile again. So this gives a 99.8% smoothness score, which is very good. There's no jerking involved, so it will never drop whatever it's holding. Okay, max velocity we've seen. Minimum velocity is 0.05. Max acceleration as well, 0.84. Really good. Success rate is perfect. It completed all the trips it was supposed to make. So total beer visits, it went for 6. An average navigation time is about 32.9 seconds, which is really good. So far, the whole mission has taken a time of 10 minutes. Okay, so let's see from this tab, we can see, okay, we went visited the tiger section twice. Okay, the Denmark once, everything else about one time. So the visit history can be shown here and the periodic updates will be shown here as well. Looking at the navigation path, we can see the path it takes, okay? It's not a orderly path because it's choosing the shortest path possible. Okay, velocity velocity profile, we've talked about it. Activity heat map is the hottest at around here, the Tiger area, because you can see this is where we visited the most. You see, we went there twice. So this is the hottest area. This side not so much, maybe only one time. And purple are the Alps which are narrowly visited. So most of the time we were on the left side of the map. And for the build history, the user can see how much they've spent on each type. So let's say Tiger went the most 24, Heineken 1, everything else about 1, and he only cost this much. So this is the total bill. So on here, the live status log, we can see everything from the beginning all the way until the end, each location, where he went, what he spent, what he has done. So let's say now a different user wants to start, you can simply just reset build. Everything resets back to start. So a whole different user can take the whole path again. So that is the overall layout of the whole beer warehouse GUI using nav2 parameters. So that is it for my presentation. Thank you.